Hello, Math 1093. This is Moving On Over. Apologies to the late Hank Williams. So this video is about the idea of a horizontal shift of a function's graph. And I have to tell you, I find this topic a little bit challenging to explain in a way that is clean and clear. In fact, I've done an entire video and decided to trash the video and start over. That's how tricky this is. So please pay careful attention and let your instructor know if you have any questions. Alright, so what we have here is the graph of a function. I'm going to say this is the graph of y equals f of x. And in fact, I'll tell you what the formula for f of x was. F of x is 2 to the x. It's an exponential function. I thought that might be the best illustration of what's going on here. Alright, so our goal in this video is going to be to graph the following modified function. G of x equals f of x minus 3. And we're going to do this without writing out a formula for what this is, although we could certainly do that. But I'd like to do this in a way that illustrates the connection between these two functions here, g of x and f of x minus. Well, the connection between those is that they're the same. Really, I want to illustrate the connection between these two functions, f of x and f of x minus 3. All right, so I'm going to approach this problem like many of the other ones by building a table of values. So we're going to put x in one column and g of x in the other column, and leave a lot of room for work. Okay, but we're going to do most of our work by reading the graph, and then when necessary, calculating something. Okay, so let's just start by putting a few values that we think might be useful to think about. So let's try x equals 0 and see what happens. So what is g of 0? Let's go and put 0 in our table here. G of 0, by definition, is f of 0 minus 3, which is f of negative 3. Okay, so now this is a place where I'm probably going to need to use my formula to figure out what f of negative 3 is. Well, f of negative 3 is 2 to the negative 3, which is 1/8. Okay, but I want to notice something as I do this. I don't want to just blindly plot points without thinking about the connection with f of x. So here's the point on the graph of f that I'm looking at. It's right there. It's negative 3, 1/8. And now what I'm getting is that g of 0 equals 1/8. So that means I'm going to get a corresponding point on this graph over here somewhere. So that's going to be my red graph. All right, so this point was negative 3, 1/8. This new point on the graph of g is 0, 1/8. Okay, so that's when x is 0. What about when x is 1? Well, g of 1 is going to be f of 1 minus 3, which is f of negative 2. And that is 2 to the negative second, which is 1/4. So where's the point on f that I'm looking at? It's this point right here, negative 2, 1/4. I think I'm going to stop labeling these because otherwise things are going to get mighty cluttered in a hurry. Instead, I'm just going to put the point on the red graph. That's 1, 1/4. So somewhere around here. Okay, all these points are really close together in the y-coordinate, so I'm looking forward to getting something that isn't quite as close. Let's try x equals 2, see where that gets us. G of 2 is f of 2 minus 3, which is f of negative 1. And f of negative 1 I can probably tell just by looking at the graph. It looks like it's at about 1/2. And if you use the formula, you see that that's right. It is 1/2. So I'm going to get a point, so that's 1/2. I'm going to get a point on the red graph at 2, 1/2. There we go. All right, what about when x is 3? So then g of 3 is f of 3 minus 3, which is f of 0. So now at this point, I really want to focus on the connection between these two values and where they live in this graph over here. F of 0 is represented on the graph right here. It's at 0, 1. So on the red graph, I'm going to have a point at x equals 3, but at the same height, which is 1. Okay, so now I want to just notice a little connection here. Notice that every point on the green graph is getting moved over by 3 units to the right. Okay, and I can continue plotting red points that way. I don't even need the table of values to do this. I can certainly use that to verify what I'm doing, but I think at this point, I'm in pretty good shape to go ahead and draw this graph. So I don't want to draw too much over here because I don't want to clutter it that much. But I think my graph's going to look like this. There we go. That's pretty good. So that is the graph of y equals g of x, or if you like, y equals f of x minus 3. And you'll notice that what happened was when we subtracted 3 from the argument, that is, we replaced x with x minus 3, we ended up with a graph that was shifted 3 units to the right. So that suggests a general principle. I'm not going to prove the principle in general. I'm going to call it the moral of this story. The graph of y equals f of x minus k is the result of shifting the graph of y equals f of x k units to the right. And there's a little interpretive thing that we need to do here in case we end up adding a positive constant to k. So let me show what's going on there. So what if I have something, for example, like y equals f of x plus 2? What would that mean? Well, the way that I would interpret that is I would say that is f of x minus negative 2. I would reframe it in terms of subtraction. And then I'd say I'm moving negative 2 units to the right. Well, what does negative 2 units to the right mean? Well, that's the same as saying 2 units to the left. Okay, so if I replace x with x plus 2, then I'm moving my graph 2 units to the left. All right, now the thing to keep in mind here, this is just sort of a caution. All right, so I'm going to put this in an exclamation mark with a little explosion bubble around it. Okay, so for this principle to work, I must be replacing all instances of x in the function formula with x minus k. Sometimes students get that a little bit wrong. They think that we can replace some of the x's, or they see that one x has been replaced with x minus k and think it's a horizontal shift. And that's not always the case. You have to be replacing all of the x's. Okay, so anyway, that's an illustration of the idea of a horizontal shift. I think that video was much better than what was going online last night at 2 a.m. So hopefully that helps, but let me know.